Okay, I think we can start now. This is the third press conference and last of the day, and it's going to be in a slightly different format as the ones this morning. So it's supposed to be more interactive. And the speakers, the chair is Herman Helds, will moderate this press conference. And he is the chair of sustainability and global change at the Center for Earth Systems Research and Sustainability at the University of Hamburg in Germany. And he's also a former division president of EGU. And you will be introducing the other participants, who will then give very, very short introductions, and then we'll open the floor for questions, which you can address to each of them. And I think we can start now. Thank you.
Thanks a lot for this kind introduction. So welcome to this press conference. And it's an interdisciplinary press conference. It's basically at the heart of the topic of our division, energy, resources, and the environment, which tries to also deliver a sort of holistic view on the mitigation options that we have. So before I introduce the other panel members, I would like to ask you to introduce yourself briefly, that we know what kind of audience we are addressing. So if this is ever possible, please circulate the microphone to the audience.
Sven Boys on the Swedish radio.
Jochen Stedler from the Austrian Press Agency.
Liz Gallagher from Environmental Research Lab.
Marcel Krok, a freelance science writer from the Netherlands.
Thanks a lot. So here at the panel, we assembled speakers from our division, and in particular from that session that tries to deliver this holistic view. So next to me is sitting Gerhard Glatzel. He will introduce his thoughts about biofuels. Next to him we have Adele Manzella, who will talk about the deep geothermal resources. And then finally Michael Kühn. He will talk about CCS, and actually he is the acting president of our division. As we all know, we have, in the view of large fractions of society, a climate problem. And now it's about the discussion what we are going to do about it. And therefore, it's very important to know about the mitigation options. And it seemed to be rather clear that there is no such a thing like a silver bullet, but we need a mix of options, and we have to weigh as a society about the right mix of these options. Yeah. So could you start to introduce yourself a bit further and to deliver your thoughts on biofuel?
Thank you very much. My name is Gerhard Glatzel. I'm in the Austrian Academy of Sciences in the Commission for Interdisciplinary Ecological Studies. I'm a forest ecologist, and I'm also engaged in the ESAC. This is the European Academy's Scientific Advisory Group, and also at IASA. What we are thinking, or what we're trying to answer, is the question how liquid biofuels, transport is mainly based on liquid fuels, cars, trucks, airplanes, and boats. And the target of the European Union is ultimately to have 20% from renewable resources. And you are also probably aware that the first generation of biofuels, biodiesel from various plant fats, it has been criticized because large tracts of tropical rainforest have been converted to oil palm plantations with negative effects also in terms of climate mitigation. Bioethanol from agricultural crops, which can serve as food for humans or feed for animals, has been also criticized because the climate mitigation on careful investigation didn't reach the expected target, and also there was this connection with rising food prices. So the big hopes are on second-generation biofuels. Whole plants can be converted, or the lignocellulose is the technical term, to ethanol. And what we try to answer, can these new plants, which need to be, because it's highly sophisticated technology, can they be fed, and can this be done without negative impacts on biodiversity, on water, on tourism, and other ecosystem services? My answer is, this is the field of my competence, from forestry in Central Europe, most likely not, because the logging residue, these are when you cut down the trees, what's left on the ground, looks a lot when you walk through the forest, but you have to think that this only happens once 100 years. The forests take a long time to grow, and if you break it down per year, it's not that big an amount. Also, you have to leave the needles and the green material in the forest, otherwise you deplete nutrients and you reduce soil function. So also forestry has, after fossil fuels had started to be used, before that they sold 80% for energy. It was the only energy, wood, a little straw fire is not important. So, but then they specialized in refining this biomass to timber, which can be used for furniture, for building, for paper and everything. So now 80% is timber, and only the rest is fuel, which is locally used for heating plants, for combined generation heating plants. So the option is plantations, and there are expectations of idle land. But in idle land, which is not used for agriculture or forestry, biodiversity is usually quite high, and fertility is low, so the expectations are not too good. So what we really want to know is that before a lot of taxpayers' money is invested in this, that a thorough survey is done in a 10 by 10 kilometer grid or so, to really know and to avoid the potential mistakes which the first generation brought.
Yeah, thanks a lot. Are there any direct responses to what Gerd has explained? Otherwise, he would hand over to the next speaker, if that's not the case. So, Adele, please. Yes.
So the main difference. Yeah. So my name again, Marcel Krok, freelance science writer. So the main distinction between first generation and second generation, could you explain that?
Yes. First generation were two pathways: biodiesel from oils and bioethanol from grains, or sugarcane, which is successful in Brazil. And the second generation uses wood or the whole plant. Therefore, the option for the second generation is either use straw or perennial grasses with tiny seeds, but with a lot of biomass, or wood which isn't used, or produced in special plantation of willows and poplars and things like that. So there are different problems. Grains you could store; they are harvested in a short time span, a month or so, but you can store them in silos. With straw, it's more complicated. It's quite loose. You have to grind it, compress it to store it. And with woody biomass, you can actually, the advantage is you can harvest it all year around, except if there's snow or the roads are blocked or so. But it's very difficult to store. It's wet, it's humid. So you have to dry it, it's not easily compacted. It's not. Once you made it into pellets, then you better use it at home for heating your house, and not for storage, because it adds costs.
Further technical questions? If that's not the case, we hand over to Adele. Please go ahead.
Hello, I'm Adele Manzella from Italy. I work in the National Research Council. I am a geophysicist, and I have been working in exploration for geothermal fields since 1990. And I'm now coordinating various projects for geothermal assessment in Italy. And I also I have been working for international projects related to geothermal energy. So I'm here to talk about geothermal energy. I prepared just a few slides to give you an idea how we use nowadays the geothermal energy and what are our forecasts, what is our forecast if our research succeeds, of course. At the moment, we are working with geothermal power generation in many fields around the world, producing 10 gigawatt, a little more than 10 gigawatt of power, which correspond to about 45 terawatt hours per year. But as you see in the map, this production is related only to a few. As you see, these areas are only related to a few peculiar geological conditions. What we want to do is to extend the use of geothermal energy possibly all around our continents, and try to use and optimize our efforts for using geothermal energy for power production and heat production, so to achieve in 2010, this is a graph from IEA recently produced, if the technology advancement that we are working at reach the target, we could in principle produce much more in the next decades. Oh, sorry. This is what you wanted to say. Yeah, I see that they're much better. So you see that in 2050, we could, in principle, if the technology advancement that we foresee are really achieved, we could arrive to produce 140 megawatts of installed capacity. Just for power, and this is only a part of geothermal, because geothermal is able to produce not only power but also heat. So a lot of research right now is working in order to, on one side, to optimize the techniques for power production. So from the same kind of resource, increase the amount of heat and power that we can produce in a certain volume of the underground. But also we are trying to enlarge our possibility to produce power and heat also for resources of lower temperature, because most of the power right now is produced by what we call high enthalpy. That means high temperature volumes of the underground. Now, a lot of efforts are put in trying to produce more power with fluids from the underground in the range of 80 degrees. This is really at the limit of what we can produce now, 85, and 150, which is a kind of temperature that we can really easily achieve in many places within 5 kilometers of depth. Moreover, we want to combine, to be able to use also these the techniques that we are developing, also to produce in a better way power and heat for many processes, because a lot of energy is used in Europe, but all around the world, not only for as an electricity, but really as heat. So we can introduce the use of geothermal in many processes, industrial processes, in the heating of ambience. And so we are working in order to increase the the effectiveness of using geothermal energy all around the world, and in my case, in the case of all the scientists are working here in Europe.
Thank you. Any technical questions? If that's not the case, yes, please.
This 10 gigawatt, how does it relate to the global energy consumption and things like that?
In nowadays or in the future, you mean?
Nowadays.
Nowadays, the graph you see, I wrote some more, which gives you an idea of what the forecast that we have is spread around the world. At the moment, the figures that you see is just for the power. I do not have the figures for the heat that we use for other processes. But the heat at the moment is not so used, not as much as we like. It is used mostly in spas, but now a lot of new projects are running for district heating, and it is clear that these techniques will grow in the near future, because district heating is going to grow in the future. And so we could add to these figures also, in particular, a lot of values, especially for district heating. And in places like in Italy, like my country, we are working to see how we can use the heat to produce freshness. If we reach enough high temperature, we can convert the cycle, and we can also cool or even freeze. So we can use the temperature, the underground temperature, even for other processes that for the moment we are not using.
Further questions? If that's not the case, please, Michael, tell us about CCS.
The mouse does that.
Come on. Yeah, good afternoon, ladies and gentlemen. My name is Michael Kühn, and I'm the head of the Center for CO2 Storage at the GFZ, German Research Center for Geosciences. And at the same time, as Hermann already lined out, I'm serving the Division Energy Resources and the Environment as president at the moment. For our discussion here today, I would like to pose the question if CO2 storage actually is a global solution to our global challenge we do have. And to give you the answer right away, yes, to my opinion, it is a global solution to a global challenge. So this is emphasized by our research. So what we know is that our emissions have a significant impact on the carbon cycle, and we do have natural analogs which prove that CO2 can be stored for long times. And if you calculate the potential, the capacity for the CO2 storage around the world, it is really huge. And from that, you can determine that CCS might provide 25% of the emission reduction potential we need in total. And on the other hand, you can learn from pilot sites like we are operating in Ketzin in Germany, that on the research scale, we can demonstrate that CO2 storage is safe and reliable. And as a further idea, which I would like to present to you here, you can see the following slide. So what we do need in the future is a huge capacity for energy storage, energy from renewables. And here you can see one idea how you are able to store huge amounts of energy in the underground. So you can combine methane, so natural gas reservoirs, together with CO2 reservoirs. So this comes together with the CO2 storage. And what you can see here is if you have surplus energy coming, for example, from wind, you can transfer it into hydrogen by electrolysis, and then you take some CO2 from the storage here underneath the methane storage reservoir. You use the hydrogen and you produce methane. And you can store it as long as you want, and as soon as you need it, you can produce the methane here, use a combined cycle plant, produce heat or power, and at the same time separate the CO2 again and bring it down into the CO2 storage reservoir. In that way, you have a closed cycle, a closed carbon cycle, completely based on renewable energy. So this is a new idea where you do have the combination of CO2 storage and energy storage. So far, my statement I want to give here at the beginning.
Yeah. Thank you, Michael, for a fascinating perspective. Any technical questions? Yes.
In which form do you store the CO2 in the ground?
So you mean here in the storage reservoir, so it is at a depth where you have it in this highly dense form, the CO2, supercritical CO2.
Further questions? Yes?
Hi, this new idea that you're talking about, what's the kind of state of progress on that?
The state of progress is that we have just submitted a patent, and we are calculating how it can come online and can work.
Mm-hmm.
Will you be working with industry partners in that?
Yes, we will, but at the moment we are investigating this from the German Research Center, and this in close relation to our studies of the CAT-scene site, which is actually that part of the idea. So this is what is really in operation, and here above you do see a former gas storage site, and there the idea comes from, is it actually possible to run several reservoirs in several levels, and in that way get rid of the transport problem.
Further questions?
So this is Rachel Berkowitz from Physics Today via Skype. Is the methane and CO2 combined reservoir actually in practice? And are there no issues with leaking fluids to the surface or between reservoirs?
So the CO2 storage reservoir is active, so we are operating and injecting the CO2. And the methane storage reservoir is abandoned, so this is an old gas storage site which is not in operation anymore. And there are no leaks of CO2 from the CO2 storage site.
Further questions? I do have a technical question myself. Why is it necessary to go through the energetically consuming step of the methanation? So can't you just store H2? I guess this is not so easy, yeah?
Yeah, so this is actually the issue. It would be much better if you could store huge amounts of hydrogen without doing the transfer to methane. But this is only possible in large salt caverns in the underground. You do not have everywhere these kind of structures, so you do not have everywhere salt in the underground where you can do it. And in porous media like sandstones, like you can see here on the picture, you cannot store on the long run hydrogen. And this is why we open up here a new opportunity. So it's less effective, but from the calculations we can tell at the moment that we do have an efficiency here of 30 to 40%. So what is compared to what we are using at the moment in fossil fuel power generation quite competitive.
Thanks. Further? Yes.
What are your logistical requests? I mean, how far away could the wind power, for example, be, and things like that? Is that a problem? To make it more concrete, in Germany, for example, are there many sites where you can do this?
Probably yes. So what we are going to assess is where we are able to do it and how large the wind farms need to be. However, to transport the power from a wind farm is probably much easier than to transport the gas through a pipeline. But the heart of the idea is to have actually no transport here and to come up with smaller solutions, because in the future we do need non-centralized solutions, different to what we have nowadays, where we have these very huge power plants of coal and nuclear. So these are solutions which are relevant for smaller sizes, for towns or larger villages, and it is best to have the wind farms right at the location, but this is definitely not necessary.
Further questions?
Yes. My name is Andreas Karl, European Research Council, and I'd like to ask about the costs of this system. I mean, so far, of course, despite environmentally very unfriendly, blowing CO2 out in the air is, of course, a very cheap solution. So having to do CO2 storage will be much more expensive. So will it be realistic that it's done in a large scale, so really having a large scale, global, at least countrywide environmental impact? Thank you.
So you are referring now to the CO2 storage itself. So if you look at the numbers, yes, it is competitive, so you can do it. So at the moment, the people always say CCS, carbon capture and storage, this is going to cost us some money. But as you just mentioned, the cheapest way we are doing at the moment, just emit the CO2. However, it doesn't matter if we go the pathway with renewables or anything else. Everything we do to reduce our CO2 emissions will cost us significant amounts of money. And if you compare the CO2 storage with other renewables, for example, you are, with the numbers we do have at the moment, at the expensive end of wind power and solar thermal. So that means completely competitive to others, which are, for example, photovoltaics, much more expensive. So yes, it is economical to do it.
Let me add to this point. So if you talk about present-day costs, you are, of course, in a static picture of the economy. Now, especially in the mitigation sector, we expect some learning curves because we are dealing with very new technologies, and there's a large potential for cost reduction if you go into mass production. And so if you implement this in an integrated modeling framework that has a global economy in its focus, then you will see that you don't have a silver bullet, but you have a mix of options. So the economic optimizer would choose a mix of renewables and CCS and efficiency and others. And CCS then, if you are prescribing something like a 2-degree target, only then CCS makes sense. Yeah, otherwise there's no benefit from it. So CCS would then enter the game, and you get a cost reduction of roughly 0.3 to 1 percent points of GDP. And to put this into perspective, the total costs of mitigation are estimated to be between 0.5 and 2% of GDP, averaged over the whole century. So basically, you would use the cost by 30 to 100 to 50%, yeah, by CCS. CCS has another very important aspect to it. This economic calculation assumes that we have a perfect cooperation worldwide, which we don't on the mitigation level yet. And therefore, we expect some delay in action, some further delay. And if we delay too much, then there's a clear message from climate science. There will be the point where there's so much CO2 in the atmosphere that without the option to net extract CO2 from the atmosphere, we cannot stay in line with the 2-degree target any longer. So CCS opens the exciting opportunity to overshoot our emissions in the first half of the century and to then net extract CO2 by using either bioenergy or using some other extraction technologies, some carbonate looping, some fancy technology, CO2 extraction, and then in combination with storing the extracted CO2 in geological formations, that would open up the option of negative emissions. And this is in that sense a very important option we should do research on. And here a second, this is what I find very exciting about this demonstration that we had by Michael, that carbon storage is becoming important in a second view now. Yeah? So as a storage for being reused. So this is, let's say, a very exciting opportunity, because then there's a scale for further cost reduction. If you have multiple uses of one technology, you may expand this technology. The other question is, of course, whether on a macro scale. So you mentioned that CATSIN is basically working, so that's a very good news. And from a joint report, I learned that in terms of being able to measure the leakage rate, so we as climate scientists can calculate how dense on average such a formation has to be, what's the mean residence time of the CO2 such that for the climate dynamics it's long enough, it's stored long enough, and the preliminary calculations clearly indicate that somewhere between 1,000 and 10,000 years of residence time, there's a threshold where CCS becomes interesting. And the exciting news from the CATSIN project, as I got it, was that you are now only, I think, 1 order of magnitude away from this, from the detection limit that we would need to be proven if we want to be proven. Yeah. There's one branch in let's say, environmental policy, where you go just with a procedural prescription saying if you obey a certain procedure, then you assume the CO2 is stored in a safe way, or any waste is stored in a safe way. So then you could already expand it, scale it up from CATSIN to any other site. But as a natural scientist, I would find it even more convincing if we could demonstrate a certain maximum leakage that has been not reached. So and if this is a very tough detection limit, then we are on an even safer side. And this is a very fascinating development that we expect over the next years, that we are able to demonstrate which sites are so dense that this upscaling is really, from an environmental point of view, something you could invest in. So as I understood you correctly, Michael, let me rephrase your statement about CATSIN. So this works. This is very good news in that sense for the whole mitigation community, because if CCS doesn't work and the action is further delayed, it's almost impossible to still comply with the 2-degree target. So in that sense, CCS is an almost necessary mitigation option. Not saying that other options are not important, but if CCS drops out of the box, then we may have to talk about a different climate target. So the question then is whether the upscaling to other formations is possible. So, but I guess you are saying the potential is there, but each formation has to be assessed individually. Is this good?
Yeah, so this is the case. So what we now need to do as community is to move to the next step. So we need the larger industrial sites to go on this pathway, and to show that the next larger step works as well in the same way. So there are examples around the world already, like the Sleipner case offshore Norway. So there you can see that it is working on the industrial scale. However, what I would like to say here is as well, so this is just one option. So what we really need to do first is to have energy conservation. What we need to have second is to use our energy more efficiently. And then third, we need to move to the other ways of producing energy. So we really need geothermics, and we really need the area of biomass and the others. So CO2 storage is something we can do now, and we can do comparably quickly, but without the other parts, the portfolio is not complete.
If I may add just a few words. We are all working in projects that combine different kinds of renewables, and also looking at research done in CO2 sequestration from one side to learn on research, because part of the research is of the same kind. We are trying to understand how the underground work in some way. So we have similar research fields, although the targets are different. But also the CO2 sequestration is also maybe in the future part of our work, because in some peculiar geothermal fields we have natural CO2, also fluids, and so we need the kind of research done in CO2 sequestration to optimize also the geothermal use. And in any case, all the projects running now in renewables, including geothermal, they try to provide as much as possible completely renewable plants. So using in combination geothermal with other renewables in order to achieve a complete renewable use of the energy and production.
Are there any further questions to the whole panel, so to the whole folder? I have a couple of further issues, but we would like to give you the chance first.
I have a question for Gerhard.
Yes,
what would you like to see EU policy on biofuels become?
Well, biofuels certainly in terms of energy is energy, and is one of the many options for using energy. A critical question is, it has always been addressed, even today, to reduce the use of energy. So you could very simply say, well, if I reduce driving speed from 130 to 110, I reach the same target. It's many other options. You could also say, in theory, you set fixed rules, as with other pollutants, to allowable emissions. We did it with ozone, with many other things. And you could say, so in 10 years, a car mustn't use more than that. This would also stimulate technology and things. But this is probably not possible. And because we like to drive bigger cars, and the real problem is the energy total consumption really isn't going down. It's clear if you insulate your house better, you save a lot of money too. You save energy, but you save money, and you spend the saved money for other things which cost energy to produce. So this is the vicious circle in all this. So when I do this practice with my students from developing countries, the only thing energy use is correlated is poverty. Poor people cannot afford energy. The richer, the more energy they spend. So we have to look at all these options which have been mentioned, which do not have this effect on the climate. And we have to make sure before we go into this next generation. There's also a generation 3, which looks very promising. This algae and this artificial photosynthesis looks probably more promising than using the biomass, because this, what I mentioned, idle land, it's maybe in some parts of the world it's there, but it has these negative effects on biodiversity, water use, and tourism, and so one has to be quite careful before we make the decisions, because as you know, this first generation run into troubles.
Now, Gerhard, nevertheless, do you see still the chance that we will use bioenergy on a macro scale? So what share of the worldwide primary energy production?
Worldwide is another picture. In Central Europe, we have a very small scale land use pattern where a lot of these options are not easily possible. Worldwide, I think you can Google and find out that the largest wheat field is about 40 or 50 square kilometers. So there you can afford the processing for the straw. You can grind it, you can pellet it, all these things that a farmer cannot do in the backyard. So globally, there's an option, but it's also it has also been very carefully investigated in terms of what it will do, because a lot of this so-called idle land is in developing countries, and there you have competition with traditional use, with medicinal plants. So what I stress is a careful and well-planned approach, not a gung-ho. So this is good for the climate. It's no question the G2 process is more efficient than the first generation process, but you have to know more about all the conflicts and try to get a fair picture.
I found it interesting that you mentioned this 10 kilometer by 10 kilometer survey that we should implement before further action is taken in terms of bioenergy policy. So maybe the science basis could be really improved here. Let me re-emphasize that without the option of net extraction of CO2 in the second half of the century, I would not be very optimistic about the 2-degree target, if you are interested in in keeping the 2-degree target. Now I have a question to Adele. Oh, sorry. Yes. Yeah.
If I listen to you, then I get the feeling that you are against the European target for biomass. Is that correct?
The question is, it should be this. You are talking about the 20% from renewable. It should be before we invest a lot. That the first generation didn't meet the target. This is clear. We import a lot of ethanol from Brazil, from North America. So we absolutely should avoid in the next generation that we have to import it from tropical rainforest or from any other part without really getting a very, very thorough assessment. And even if you talk about Central Europe, you have these rural areas which have their problems, which are complex. It's fair to feed them, but if you make a lot of plantations, you need a lot of machinery. You convert existing forests maybe in plantations. It's very difficult to reconvert. It has effects on the people living in the area. So you have to really do a very thorough thinking. It's so sort of the only driving factor. Has a better potential for carbon emissions reduction. Shouldn't be the only one, because then the other problems might come up and might stop it.
Further questions to Gerhard? Now, Adele, you mentioned the future role of geothermal energy. We had in an EGU journal, which is called Earth System Dynamics, a very interesting publication last year about the limits of wind energy, the thermodynamical limits of wind energy, or at least the limits in terms of when would it environmentally matter that you extract so much power from the jets. And it turned out that, in fact, if you were in a thought experiment where you had to feed the whole world only with wind power, that you are reaching a limit where it environmentally matters. So you are modifying nature then, yeah, on a large scale, on a macro scale. The author suggested that with solar energy that might not be the case. So in that sense, wind is more complicated. Now my question is there any talk about the intrinsic limits of geothermal? Is in your environment, is there any discussion about that? Is this an issue?
Not in my knowledge.
Okay. So there are other, yeah.
But if I think about it on the spot, geothermal is not exactly the case. The thermodynamic limits we are already touching, and we are already working on that. So we are making things more efficient, and we are working with that every day. The difference is that we have this heat underground everywhere, and we can just go deeper to find a higher temperature. So it's the limitation in geothermal, I think, is should be considered in another way. We are improving our capacity to take care of medium temperature, as we call. For the moment, we are mostly producing power with high temperature, but we are enlarging and making more efficient ways to use an average temperature, which can be found at relatively small depth. But we can also go deeper to find this temperature. So it's technology is going in the direction of reducing the cost for doing that. But limitations are far away from a certain point of view. Is a matter of economy, not so much about thermodynamic or technological.
But maybe ecology? If you pump a lot of heat out and use it to heat your homes, your water, and so some of that heat will go out into the rivers and in the surface water, so you might have there an effect. So,
but we are going to use that in cascade. So in
you
series,
bring it down to the very same temperature as the river.
Then we reinject everything underground as with zero emission and using the heat at the very last. The heat is renewable, because it's just a matter how quickly you extract the heat, but it is continuously released from the subsurface. So it's the limitations are different in a certain way.
I can tell from the discussions with the other colleagues from the energy economics that I would say the majority is a bit skeptical about the cost reduction potential, but maybe this is a false perception. So my impression is that there could be an enhanced dialogue between the two communities. At the moment, geothermal is not playing a major role in most of the climate economic assessments. Yeah, the optimizer doesn't employ a lot of this technology. The investments, the massive investments, are into wind and solar, and a little bit of biomass. This is the coverage on the renewable sector, and maybe there's a false perception of the potential of cost reduction. And the interesting thing was that in some chapters of the renewable report of the IPC, so the special report on renewables that was released last year, I got the impression that the engineers are sometimes more optimistic about the cost reduction potential than the economists themselves. So this is an interesting perspective for further research and collaboration. Then I have a related question to both of you. Sorry.
We just have a couple more minutes.
Yes.
So if you could also, if there's any other questions from the floor, maybe we could give priority to that.
I don't want to disturb the session, of course, but no. What I'm missing a little bit so far is more the global picture. Of course, I understand we cannot treat everything in such a short session, but could you, speculate a little bit about what's going to happen? Because we now know that China is growing. The CO2 emission of China are growing with the total emission of Germany every year. So this is the reality, and I don't think this is going to change very soon. So I mean, from that perspective, what is going to happen? And yeah, maybe we could discuss that for a little.
Mm-hmm. Does anyone want to comment on it? I could comment on it a little bit, but you should start first, perhaps.
What needs to happen, I mentioned with regard to CO2 storage, so 25% roundabout, maybe a little bit more, could be the part coming from there. And this needs, what we need there is to implement this technology within these countries where the emissions are going to rise during the next decades, and most likely based on fossil fuels. So this is what we need to do there, and there is a large potential coming from the CO2 storage side. Yeah, so this is what I said. It costs money. So the cheapest thing, or maybe it's not the cheapest, Hermann can say something to that. So if nature hits back finally, when we just do not change anything now, it's definitely is going to be more expensive. But now, we have to invest money here.
But is China going to do that? I don't think so. I mean, they need so much more energy. And I mean, every coal power station, I mean, every new coal-fired power station that they're going to build, they're going to use for the economy and not for putting the CO2 of another power station underground.
So what I know is that they are at the forefront of research as well, but what we really need to do here from Europe, or the rich countries, provide the technology, and then which technology have not been used by China and these other countries. So if we can deliver, they can use it.
Well, if I say something as an ecologist to this, it's clear that we lack a really good mechanism for global governance. And in addition to this, there are habits. I mean, it's for us, it's crazy to eat rhinoceros horn or so, but still it happens. And we know that we should eat less meat, and we could solve the problem. Still, we do it, and half or more than there are hungry people in the world, there are obese people. So I think in some areas we have to really think. Not globally, but in terms of what we can do and what rules we can make for bringing this down. It's not. I think, in my opinion, getting more energy for using is just one option. The other is finding ways to bring this use down, and possibly you need rules and laws.
What I say is, research requires time and efforts, and it's always like this, but the culture is moving, and it will take some time, but we are going in the right direction. That is the most important thing. It will take some time. We still have fuels, we still have fossil fuels. The important is to go in the right direction, of course. So I am optimistic from this point of view.
So since you were asking about the global picture in a sense, so one message that we learned over the last 5 years was that the overall costs of the 2-degree target are not that dramatic. Yeah, so in principle, we can have continued economic growth, worldwide growth, and we could have a policy in place where we comply with the 2-degree target, and the average loss due to the 2-degree target, loss in the sense of the costs of mitigation, are about 1%. So this is the number that you can find in the Stern report already in 2006, and it has been further and further confirmed in further model intercomparison studies, and it will be further investigated. So it's not, the discussion is not completely over what the costs of mitigation are, but this seems to be a stabilizing figure, this 1.5 to 2% of GDP. So this is a good news in the sense that now you have a space of maneuvering for climate policy. We are not in a tragic choice, we can have both. And now the question is how to organize this. Indeed, it's a matter of organizing the global commons to deal with the free rider problem. So mitigation, worldwide mitigation is a dramatic problem because we have to organize that most emitters do participate. If only Europe is implementing a mitigation strategy, we would cover on the order of 10% of the future global emissions. So this would not solve the climate problem. So the question is how can we get the global climacy going? And the dramatic thing is that the window of opportunity for the 2-degree target is on the order of 10 years, because a major fraction of the European and also the American energy park has to be refurbished anyhow, and the investment have to be undertaken. And if here decisions are made that are at odds with the 2-degree target, then very later on we are in a tragic situation. Yeah, let's say 20 to 30 years from now, we have all these coal-fired power plants in place and without CCS, so in a business-as-usual scenario, and it's very costly to radically change that. So now is the window of opportunity. in addition, because, as you mentioned, the emerging economies are massively investing in the energy sector right now. So this is a very short window of opportunity for the 2-degree target. And therefore, we have to get the science straight rather quickly. The science in terms of, when I say science, I include economics as well. So how to tackle the free rider problem? On the one hand, there are the conferences of the parties. So for the first time in 2010, now the 2-degree target, which was proposed by the European Union for almost a decade, was now adopted under the UN framework. So this was some progress in that sense. But if you look at the binding emission cuts, then there's a vast gap, as we all know. So how to deal now with this gap? And there's a competing mechanism. It is not substituting the conferences of the parties, but individual actors are free to make coalitions among the willings. For example, the European trading system could try to link itself with other trading systems or emerging trading systems. And it's very clear. Europe has a front-runner position at the moment. It is assuming this position. On the other hand, if it's only us who invest into mitigation, all the others don't, then we have, on a, let's say, 10 to 20 year time scale, an economic disadvantage, because we take the costs and others don't. So it is a function of how many participate, how far you can go as a front runner. So we have to find as many allies as possible. So this is this coalition formation procedure, and this is a branch of economic investigation, how you can stabilize such a coalition. So this is one branch of research that could help here. And that's right. I agree that it's for mitigation from a global point of view, it's good if a lot of technology is transferred from Europe to other nations who could absorb it, and in particular the emerging economies which have a lot of coal at their deposit, like India and China. CCS could be extremely attractive. On the other hand, it is also maybe not clear whether it is really economically valuable if only some actors do all the investments and then give everything for free. So maybe it's a joint thing we have to undertake in the future, a joint development of new technology. So we may need a technology protocol that not a single country has to pay the first part of the learning curve and then others take over, like we see it in one of the renewable technologies right now. But we should have a joint action from the beginning in these investments. And this, I think these are two economic instruments we could put in place with this coalition formation and together with the technology protocols, where then there is a higher chance of stabilizing the expectations in the implementation of a global mitigation policy. And here a lot of scientific input is still needed. Of course, you can be brave as a politician and sign a contract, but I, as a politician, would like to see a bit more clarity in the consequences of the signature.
Thank you very much to our excellent panel of speakers. I'm afraid we have run out of time, but if you want to ask more questions, you are welcome to book an interview room and speak to one of the panelists. The next press conference is tomorrow at 10 a.m. on uncovering the traces of the Great Tohoku earthquake. Thank you. Thank you.